This is Martin Carlisle with Buffer Overflow 3 from pico2018. 2018. Looks like Dr. Zernon added a stack canary to this program to protect against buffer overflows. Do you think you can bypass the protection and get the flag? You can find it in this directory, and we have the source code. Downloaded the source code. Here's my vuln method. It's going to ask how many bytes I will write into the buffer, get that number, and then it's going to let me read from the input as many characters as I want. But there's this canary which is on the stack, and it will check to see if that canary has been changed. It looks like the size of the buffer is 32 and the size of the canary is 4. Now, so maybe there's a smart way to brute force the canary. So I think what I'll try to do here is I'll start with sending 32 characters. That should work fine. If I send 33, that'll probably mess up the canary, but I'll only have to look at 1 byte of it. And I can try to loop through a whole bunch of things and see if I can find the 1 byte of the canary for that first byte that's correct, and then I'll repeat that, and hopefully I'll be able to get the entire canary and then the flag. So I'm going to create a program for this. And I'm going to use something called Pwn Tools. This is a good way for me to interact with a process. And I said I was going to try to loop through, so I'm going to loop through all the printable characters. I'll create a process. I'm going to send 33. And I'm going to send 32 A's plus this character that I'm trying. All right, so now I'm going to receive the response. And I'm going to ask if it says OK. All right, so we are looping through all the printable characters. We're going to send 32 A's plus this thing. We'll do a receive. If it says it's OK, that means I have the right thing. The canary is not incorrect. And I'm going to print that I found it. All right, so it looks like the first byte of the canary is H. So that's great. So what we can do now is we can just change this program. We'll send the H. And now we have a dash. Underscore, really, rather. Try that again. Now we have a question mark. And now we have an equals. And that should be the 4 bytes of the canary. Okay, so we have the 4 bytes of the canary. And we now need to find how many more bytes I need to get to that return address and what the return address is. So my win method is at 080486 Echo Bravo. And let's figure out how many bytes I need to get to that return address. Okay, so here we are in the vuln method. There's the read. It's 48 bytes away from the frame pointer. Then we have that old value of the frame pointer. So we should have about 52 bytes that we need, and then our return address. So 52 bytes, and then our return address, so that means I need 56 bytes. So 3240. So we need 12 more. I'm not going to need that anymore. And then we're going to put in this return address. Okay, and let's see. We don't actually even really need to do this in a loop. I'll just print that. Yep, don't need to grep for found anymore. Okay, now where's the flag? Okay, let's look again. $32, $36, $48. Oh, that's a problem. Okay, so we're gonna change this. And I'm gonna go ahead and say p.interactive in case there's more than one line of output there. And there we go.